Hello, this is Mark Osborne, Senior News Editor at PV Tech. Welcome and thank you all for joining us today for this PV Tech Tech Talk webinar with Seraphim Solar and SMA Solar. Today's webinar will start with a presentation from Ray Wang, Regional Sales Director at Seraphim Solar. He will look into the details of Seraphim's 182mm S4 series large area modules, which have been specifically designed for utility scale PV power plants. This will be followed by Charles Wang, Sales Director for Greater China at SMA Solar, and he will be looking into the inverter options and benefits that maximize plant performance in the new era of large area modules. We will also have around 15 minutes for Q&A at the end, so please feel free to post questions on this platform throughout the webinar, and we'll try and cover as much of these as possible in the time allocated. And we also have staff from Seraphim that can also answer questions on the platform today. Well, that's it for me for a while, and happy to hand over to Ray Wang at Seraphim to start this presentation. Thank you, Ray. The floor is yours.
Hi, thanks, Mark. Hello, everyone. Thanks, everyone, for joining us this webinar. My name is Ray. I'm taking care of the sales for Asia Pacific market and mainly Australia and Southeast Asia countries. Today we're gonna introducing the latest S4 series solar panel equipped with a 182mm solar cell. And before we get into the details, let me generally introducing the background of Seraphim. Seraphim is one of the top solar panel manufacturers, and we started our company back to 2011. And after years of development, now Seraphim has been rated as a Tier 1 brand by Bloomberg, and also rated as a top performer by the PVEL. We have more than 1,500 employees, including more than 100 engineers. Currently, we have an annual capacity of 5 GW, and at the same time, we also have some new production line under construction right now. Seraphim has already shipped more than 8 GW solar panel for our customers all over the world. For the manufacturing facilities, we have 5 factories in China. We have 5 factories all over the world, 3 of them located in China and 2 overseas. And we also have a 15 sales office. And with these facilities and office, Seraphim is able to provide quality products and also flexible service for our customers. In the past years, solar PV industry has had some significant improvement. It was once heavily dependent on the subsidy business, and now it has become one of the most affordable and environment-friendly energy source in the world. And all these are made possible by technology innovation and resulting in downwarding LCOE and upwarding module efficiency. As you can see on the table in the left, shows the lowest global PV project bidding price dropped dramatically between 2013 and 2017 and kept going down smoothly thereafter. We have also saw some really amazing PPA price in the last few years. And now, as you can see on the table, the record of solar PV bidding price is only 1.32 US dollar cents. And I'm sure the record will be break in very soon. So meanwhile, all of this has made solar PV business growing into a 150 gigawatt in 2020. And on the other hand, the unit energy cost for solar energy, which we call LCOE, has also has some very big improvement. The LCOE of PV energy in 2020 is almost 1/10 of that in 2009, as you can see on the chart in the right. And all of this has been made possible by a combination of technology innovation, economics of scale, and manufacturing experience. Personally, I have joined the solar PV business for almost 10 years, starting from 2011. And I still remember in the beginning, we were selling the panels by like $3 or $4 per watt. And now it's only around like 20 US cents per watt. And the feed-in tariff in Europe, it was like 60 euro cents at that time. And now, and more countries, there is no feed-in tariff anymore. And the solar energy has become very affordable to most of the countries right now. According to the Bloomberg, ongoing reductions in equipment cost and improving efficiency and decline financing and development cost are expected to further cut down the global benchmark LCOE. And as everybody can see from the picture on the left, we are in the very, we can see the LCOE in 20 years or 25 years, it will become nearly 25 per megawatt hour. And at the same time, we can see the solar panel, the solar module efficiency has some very big improvement as well. Module efficiency continues to improve year on year, driven by the manufacturing innovations and a shift towards the new PERC and half-cut cell technology, and as well as the large wafer. Along with the growth of global PV market growing, more and more investment has been put into the solar cell research, especially in the last 3 years. We have seen some changes both in the dimension of the cell and also the efficiency of the cell. We used to use the 5-inch and 6-inch solar cell for quite a few years, and start from 2018, we have seen so many different solar cell dimensions, including 157 millimeter, 158, 161, 166, and now we are launching this latest 182 millimeter solar cell. And all of these actions actually are behind one goal, which is to improve the panel efficiency so we can reach as best as the LCOE to make the solar energy competitive, even compared to the traditional energy source. With this change of bigger and bigger solar cell, and as you can see on the chart, back to 2017, everybody was offering like 370 or 375 for the 6-inch solar cell. And 2018, when the 158 millimeter solar cell is available, people they are able to offering a 415 watt per solar panel. And last year, it reached 445 with 166 millimeter solar cell. And now, according to our latest 182 millimeter solar cell, the solar panel output has become 540. And also as well, the solar module efficiency has improved a lot, growing from 19.2% to more than 21% in this year. And let's move to the next page. Here are some technical data about our S4 panels. As you can see, S4 panels, we are launching a 144 half cell, and the highest power output can reach 540, and the dimensions is roughly 2.2 meter multiple 1.1 meter, and the weight is around 28 kilogram. This is the single glass, we call it monofisher. And at the same time, we also launched our bifacial version of S4 panels. The front side is the same as the monofisher, 540 watt, and the back side, it can reach roughly 395 to 410 watt, and the dimension is roughly the same as the monofisher, but the weight is a bit heavier than the monofisher. It is 32 kilogram. These are the most popular two different models everybody's after right now. And let's move to the next page. We can see the difference between the monofisher cell and the bifacial cell. So basically, the tracking system is widely used in the utility scale now, especially in some of the markets like United States and Australia and like Spain and Middle East, etc. So the bifacial technology is getting more and more popular. The most important point is when we use the bifacial panels, you can have roughly 10 to 30% in some very good conditions, more output. We list 3 typical environment conditions on the presentation, as you can see. In the asphalt ground. So basically you can get roughly 7% power generation. And also when you use the bifacial on the grass, you can get roughly 10%. And when you use the bifacial in some snow area, like north of European countries, you can roughly get a 15% more output. So Seraphim S4 panel half cell, we have a back gain of from 10% to 30% in different installation environments. Ideally, the module can reach a maximum output of 700 watt from the front side and the back side together. And the dimension has become bigger. That's not the only difference between our S4 and S3 panels. And as you can see, in the S4 panels, the bus bar has increased from 5 bus bar to 10 bus bar. And also, we have a small innovation on the ribbon we're using. So the 10 bus bar increased the efficiency light receiving area of the cell, and the optical utilization rate of the ribbon area is also increased from less than 5% to more than 45%. And it shows very clearly on the picture. So with the traditional ribbon, it's a flat ribbon. So when the lights hit the ribbon, it will block a certain percentage of the solar cell and reflect the light right away. But with this round shape ribbon, it can reflect the light to the other side of the cell. So the optical utilization rate of the ribbon area will increase a lot. And this also will improve the solar cell and the solar panels efficiency. And another major difference between the S3 and S4 panels is with S3 panels, the gap between the two cells is roughly 2 millimeter. And in the S4 panels, it is only half millimeter. So basically, this means with the same dimension of solar panel, we will be able to put more cell into the same area. So this is also one of the methods we can improve the solar panel efficiency as well. And after we launched these S4 panels, we did some of the testing with our S4 and the old generation panels as well. As you can see, it clearly shows on the picture that the S4 panels are more actively responding to low irradiation and remained functional at a low temperature and resulting in a higher power generation. This is due to the constant improvements in the solar cell surface texturing, like threaded structures to facilitate the absorption and reuse of sunlight. So basically, the S4 panels is able to active the solar inverter earlier in the morning, and also when the temperature goes higher or goes lower, the better thermal coefficient will make the S4 panels have a better performance compared to the old generations. And also, the solar panel, it doesn't work independently. We have to put them into a system. So we did a lot of the research to check the compatibility with the inverter, the mainstream inverter like SMA. We've already have some very mature solution for this big wafer solar panel in the market, and also the tracker has already updated their solutions compatible with this bigger cell panel. And also, as everybody knows, that the solar panel mostly made in China, and we need to ship them all over the world with the container load. So the 182 millimeter solar cell is perfectly fitting the container loading dimensions. So we can roughly loading 20% around more in the watts. So previously we can load roughly 270 kilowatts. And now with this 182 millimeter solar panel, we can load more than 300 kilowatts. So the transportation cost will be lower. This is one of the way to improve the LCOE as well. And also the weight of the solar panel is still in the range of 2 workers can handle them and install them handily. So all of this compatibility is not a problem to the current solution and to the current installation. So it will perfectly fit into the current technology. And we also took one of the typical location in China, and we did a simulation to compare how is the S4 panels is going to affect the LCOE when it comes to compare with the S2 and S3 generations. So we picked Qinghai, which is there were lots of solar projects installed in the area, and if you look at the irradiation, it will be similar with Spain and the middle of United States as well. So as you can see clearly from the picture, the S4 panels has some advantage when it comes to the module efficiency, when it comes to the extra output, the mounting system, the land, the cable, the installation cost. So after taking all of this into consideration, so we can see that the LCOE is 4% higher, 4% lower than the S2 generations. So basically, when we look at a utility scale solar project, the typical return of investment is roughly 10 to 15%. So 4% better is a significant improvement. So we think that it will become a mainstream product when the main solar panel manufacturers, they are all pushing this technology. So we, including some of our under construction production line, Seraphim will be able to start the mass production from the first quarter in 2020. And we've planned a 3 gigawatt annual capacity in this year for S4 panels. And I'm mainly focusing on the Australia and the Southeast Asia countries, and a big part of our customer is working on the rooftop markets. So the panels with 144 cells is too big for them on the rooftop. So additionally, we specially designed a 54 pieces solar cell, which gives output roughly 400 watts. So this one will be a perfectly dimension for the rooftop markets. And we're gonna introduce more details to our customers later on. So yeah, I'm pretty much done with the all of our information for these new products and for our company information. So now I'm going to pass this to Charles from the SMA. Let's welcome Charles.
Thank you, Ray, and hello, everyone. My name is Charles. I'm from SMA Solar Technology. I'm responsible for the sales market in Southeast Asia and entire APAC. Today, I'll be sharing a lot of information about the SMA Solar Technology and also the bifacial panels in regards to the large size of the panel as well. So this is our agenda today. First of all, I will be going through some memory lane regards to what has the SMA Solar Technology has done, some history about it. The second part, we'll be talking about the bifacial panels and what does it mean on the inverter side. And third part will be the 182 solar panel compatibility. Again, we will be going to a little bit of a deep dive on the specification of the panel specs. And last but not least, what we offer from SMA Solar Technology, that the range of inverters, including the string and also the central. So as Ray previously mentioned that there was a time when the solar panel cost was $3 or $4 per watt. That's actually similar to what we have in the inverter industry. As you can see, that SMA was actually founded back in 1981. We only started to develop the PERC inverters from 1987, and as you can see, that the blue one, that was the first ever Sunny Boy that has been manufactured. And at the time, if I remember correctly, that was actually less than 1 kilowatt, and the size is already bigger than the 5 kilowatt inverters nowadays. So as you can see, the technology actually developed quite a lot. And ever since then, SMA has been concentrated on the getting more equipped on the technology side. We obtained more patents, and we try to manufacture the best quality inverter in the world, and not just the string side, but also for the central inverter side. And so yeah, and this is actually we're close to 40 years of operation, and it was a very long run. We have seen a lot in the solar industry, ups and downs. So as you may know, just a little recap, SMA is a #1 European PV inverter, and actually now it's a storage as well. Storage inverter manufacturer brand. We're all designed and manufactured in Germany, in Kassel. We have about 95 gigawatt of installed inverters in the world so far, and across 190 countries. And we have about 3,000 employees across 18 countries, more than 650 sales and service team. Okay, so that was just a little recap on what is what is SMA and where we're from. And now I'm going to concentrate on the key topic today. That's the bifacial panels. From the inverter side, what does that mean, and what do we need to double check? So as Ray previously mentioned, basically the bifacial solar panels have their backs covered in either transparent sheets. It could actually gain some additional power gain, and depends on the different service as well. So as you can see, that start from water and all the way to snow, the reflecting coating roof, that all have different rating of backside additional gain. And you can see that the best ones actually from newly accumulated snow, which they can reflect up to 25 to 30%. And the reflection rate is very, very high in this case. And what does that mean? That means that on the DC side, it will be increased on the output. So that let's say if we have a 10 kilowatt of solar panels, if the ratio, let's say the DC AC ratio is 1:1, that means we install a 10 kilowatt inverter. But in the reality, that the output of the DC side will never be at 10 kilowatt due to a lot of losses. That includes temperature, that includes the dirt. And a case study back in 2006 by the Solar Energy Research Laboratory in Brazil, or what they did is they conducted a research on the DC-AC sizing ratio. And as you can see here, that if you use a 100%, which is 1:1 sizing ratio, like I said, the 10 kilowatt range, you only get around but less than 9 kilowatt, and you will need to oversize on the DC side to let's say that's 1.1 and that's 1.2. So you need to go to about 1.1, between 1.1 and 1.2 to be able to reach the actual 10 kilowatt output as you imagine. So basically that gives us a sign that's saying the more on the DC side, actually it's good. You know, we want to design more on the DC side so that the output of an inverter can be maximized. And that is what the bifacial panel essentially meant from the inverter point of view. With the different servers that can have additional gain, that gives us a additional DC power, which means it can give us more AC on the range on the AC side. And this actually aspect will be written in most of the inverter data sheets. When we say here we highlighted this in the maximum PV array power. For SMA inverters, the DC and AC power ratio can go all the way up to 150%. This is obviously to ensure it can cover the maximum gain from the bifacial panels or just any panels, basically. But reality is that the increased DC power, it will increase the inverter output. So this actually, from the customer's point of view, it's really important that they check the maximum PV array power rating of the inverter, make sure that the maximum allowed DC range can be covered with that additional gain. And here I will share a very, very special reference. This is a research station in Antarctica. It's called Princess Elizabeth. It's a off-grid system, and as you can imagine, because it's all covered in snow, and the special part about this system is that the panel that they use is the bifacial panels manufactured by LG, and the whole system will be generated. The PV side, they use about 25 kilowatt of inverter on this the newly updated back in 2019. So this system, they have their own battery, and we use our battery inverter, which means that during the daytime, when there's excess of solar, including the additional gain from the bifacial panels, that we can store the energy to the battery. And then at nighttime, or as we know that in Antarctica, it's probably a very, very long night or a very short night, that they can use the battery power to supply the loads used at the research station. Okay, so that was a brief introduction on the bifacial panels. Now we could go further to the 182 millimeter solar panels compatibility. Again, from the inverter side, what is what do we need to check on the specs, and we go a little bit deep dive on that. With regards to the 182 millimeter solar panel compatibility, from our point of view, obviously that comes with the lower LCOE and BOS costs. And what we need to check are the three very important aspects. That is the maximum power, first of all, and the second is the maximum power voltage, as you can see here. And thirdly, the current, the maximum power current. And you'll find that for most of the large-scale panels, these three parameters will just increase and increase and more. And the bigger it is, the higher the value is. And up to a point that you will need to check again at the inverter side whether it's compatible with your inverters. And this is actually quite an important thing, because that it has to be compatible with the inverter. Otherwise, your system may not have the maximum output gain. So with SMA inverters, for the large size panels such as 182 millimeters or even the 210 solar panels, we have the inverters with 1 MPPT only. That basically can easily cover the total combined currents, as all the strings we previously mentioned can be parallel together and put it into the combiner box. As you can see, previously, each of the panels add up together. If it's 13 strings, it will be less than 180 amps, which is the maximum current allowed for the string inverter, 150 kilowatt inverter. If the customers decide they want to use this central inverter, this is an example, by the way, the 2.5 megawatt, again, they can use multiple strings combined together with the DC combiner box easily. So with the inverter of 1 MPPT, it has no issues at all, because we just simply added up, parallel up the strings in parallel, and just to make sure that the current is within the limit, and that's fine. So this gets a little bit more tricky and interesting when you have a multiple MPPT inverters. So in this scenario, our we call Core 2 inverter that has a 12 MPPT, and again, in this scenario, we can actually check the maximum power current, the IMP, because this is all lower than 13 amps. So for this inverter, that it can allow to connect 2 strings into 1 MPPT, that still gives me less than 26 amps. Then we have 12 MPPT on there. So add up together, again, it will be compatible. So this is actually a very important part that the customer need to check when they do the design. And when it start the design phase, they need to double check on the match, whether the panel is matched with the inverter. And luckily for our inverters, it can basically match with all the large scale panels, not just the 182, but also the 210 PV module. Okay, so last but not least, we'll be talking about a little bit on the solution from the SMA Solar technology, that including a very simplified version on the solar portfolio. Again, like I said, this is a very simplified version, as we put the energy monitoring. Obviously, we do have a lot of manufacturer design string and central solar inverters. Apart from that, we also do the battery inverter as well. And again, we have the string and the central battery inverters. We can now even, for the PV inverters, there's an option to add a DC-DC converter, which means that one inverter, one section that can connect the panels, the other section through that DC converter, it can connect straight to the battery. We do, we have a lot of investment on the energy management. This is more at the Europe side, where they have a very high electricity prices cost, and they want to use the PV to minimize the cost, the electricity cost possible. So that we will need to use our SMA, the platform, we call it the NXOS. And in future, we can actually do even energy market integration. We can do the direct selling solution on that. So as previously mentioned, when we concentrated on just the PV sector, we have the 20-foot, we'll call this medium voltage power station. That basically means a 20-foot container with the PV inverter, with the transformer, the medium voltage transformer installed in the middle, and also the switchgear at the back. We have the 40-foot container, which means that we have two central inverters installed, one medium voltage transformer in the middle, and this whole unit can go up to 6 megawatt size. Our PV inverter, like I mentioned previously, we have a wide range of sizes available. Now, actually, the biggest one that we can go up to is 4.6 megawatt, and that's the large scale for the project solution. We have the for system control for the PV large scale plant. We have the power plant manager available that can control, send the commands, and communicate to SCADA of the grid utility, and they can send out the commands to control the output of the inverters within seconds. We offer quite a few supports, including the warranty and extended warranty, and also we do engineering service, depends on where location you are at. The commercial side, in this case, we have from the smallest goes to the 3-phase 15 kilowatt, all the way up to 150 kilowatt. In the previous scenario, we mentioned on the two models of the inverter, one is the 150 kilowatt, that's right here, and the other one is the multiple MPPT inverter, that is the 12 MPPT that we call Core 2. We also have 50 kilowatt unit, and also from 15 to 25 kilowatt range. So as in pick 3, that's our 150 kilowatt inverter. The special thing about this one is not just that it only has one MPPT. The DC input is actually 1,500 volts. As you may know, that in large scale nowadays, we are trying to push for the 1,500 volts the design, as it actually can save a lot of upfront costs. And that is the future, the trend that it will be. The inverter has 99.1 of maximum efficiency, and the full loading output all the way up to 50 degrees Celsius. The inverter itself, it has the open Modbus TCP interface, which allows the again utility that can, if they wanted to do the control and collect the data, they can just through the Modbus TCP, and on each of the device has its own IP address, and they can collect the data that way. The inverter itself, we tend to use what we call a central commission and monitoring, which means that the inverter itself will be most likely grouped together in the same plant, so that it's much more easier to do the service and to check from the utility side as well. And I think that is the end of my presentation, and I will hand it over to Mark. Thank you.
Well, thank you very much, Charles and Ray. Really good presentations, lots of really good quality information for everyone, and there's some really good questions here that have come through on various different levels. Perhaps I'll start with you, Ray. If we look at, you made some very good points about the bifacial technology developments, and also obviously for monofacial large area panels. And obviously we're seeing, which has not been talked about a lot, but obviously you're improving the low light conditions, the temperature coefficient is reducing, and so therefore there's extra performance, that it's not just about the large area wafer and the large area module. It is actually about the technology that is giving that improvement. Where do you see, what's the trend there? Are we going to see continued improvements in low light conditions, as well as a further drop in temperature coefficients?
Thanks, Mark. That's really a very good question, because currently for the whole industry line, everybody is contributing their parts to improve the key material or some of the other technology. For the end of the day, everybody is targeting on one goal, which is to reduce the cost of solar energy. So the low lights irradiation performance is actually one of the key parts of the solar panel. The engineers of the panel factories, and they are working on this one. And I think the trend is on the different technology of the solar cell, which including the P-type, which is the mainstream we're using right now. And I've seen a trend of N-type technology on the market. There are more and more companies, they're investing a lot of money on the research. And I've also see a lot of big companies announce the big investment on the N-type technology. And the N-type is definitely having a better degradation and also better performance on the low light irradiation.
Okay. The next question for you. People always ask this, which is understandable in the position we are with the rollout of large area high performance modules. But people obviously want to know if they can obtain PAN files for obviously for the PV power plant modeling aspects. So just to let people know, I'm assuming, you know, when people need that information from your modules, you're able to provide that.
For the data sheet, for the PAN file, for all the other necessary information, if you have already have a contact from Seraphim, you just talk to him. And if not, you can just simply write an email to the info.com, our company's email address, which you can find on the company's website. And then we will distribute those emails to the regional sales guys. And then we will send all the necessary documents to you directly.
Got it. Great. Another aspect, which I'll go back with, ask this of Charles. When we talk about the bifacial modules, obviously one of the trends we've seen, you know, obviously taking back what I'd asked Ray about low light conditions, you know, these modules are better at low light conditions. Also, we're seeing improvements in the temperature coefficient. But I've also noticed, for your question for you on this is, you know, you've got string inverters with, say, you've got 12, you know, multi-power point technologies. Is the trend to go more and more, to higher MPPT technology, and also whether the algorithms are matching these bifacial modules closer than perhaps was originally thought. Just wanted to get an understanding where you see the trend is, especially with bifacial modules, Charles.
Okay, understood, Mark. Yes, the current trend does get more like more and more. The more, the better. But currently, I think string inverters up to 12 MPPT or even 14 MPPT. That is probably the maximum that it will go to. Needless to say, the more MPPT, it increases the number of components in the inverter. And then obviously, as we know, increase the number of components tends to, in the long period of time, that it will be, let's say, increase the failure rate. So that's why when we see like a large scale solar system for, let's say, central inverters, you don't see a multiple MPPT inverter being installed, or let's say the multiple MPPT central inverters, and that is the reason why. But obviously, for the small commercial market or even for the residential market, yes, that I reckon it still will be there. To your second question, yes, for these type of panels, such as the bifacial panel, each MPPT, you need basically looking at the limitation for each MPPT. If one MPPT, let's say, they has a maximum current limit or the maximum power limit, then that needs to be checked closely. And as far as I know, yes, there are some market products on the market that's not compatible with the, let's say, the large scale panel, or the bifacial panels. Sorry, yeah. So, that needs to be checked thoroughly for sure. Yeah.
Okay, no, that's great. Yeah, it's this topic is just not going away, so to speak. There's still a lot that's going on that people, and I think it's as Ray mentioned, we're only seeing more and more attention to like people shifting. Well, ultimately, we'll shift to N-type and other strategies, and I think this keeps the pressure on for the inverters to actually match these modules much more closely. And I think there's a lot more that we'll see coming forward. Back to you, Ray, just for a quick one. This always crops up with bifacial. Some companies have a strategy of being only using glass. Of course, people are concerned then about the overall weight of the modules, how that impacts the actual installation, as well as also the transportation costs. But at the same time, other companies have a strategy of using both, having available a transparent backsheet version, which obviously will be lighter than the glass versions. What is Seraphim's strategy on transparent backsheet compared to just glass?
Thanks, Mark. We at Seraphim, we've never stopped our research on the transparent backsheet material, because it has some advantage compared to the double glass. First is the point that you mentioned, that the bigger panels is getting heavier, so it will be helpful to reduce the weight, and it will be easier to transport and to install them. And another thing is, maybe everybody has noticed that the price of the solar glass has increased a lot, like crazy in the last few months. So this will also push the panel companies to speed up on the implementation of the transparent backsheet. And we are already working on that. I think we will be launch these new products maybe later this year, and I think in the Q3 maybe. That's our current plan.
Okay. Another one here, another question coming through, and again, this one is, I think it's a difficult one, but Charles, give some advice here to people when they're viewing whether it's best to use a string or a central inverter for utility scale projects. Where are we going with that trend? Is it very much to the string inverter, or are the benefits of central still to be to respect central inverters for what they do?
Yeah, this is $1 million question, actually.
Always, it's always.
As always, yeah. When I've been first into the market, we have been already asked these questions. Yeah, to be honest, what we normally, because SMA has both. We have the string inverters, we have the central inverters. So we tend to let the customer decide based on a lot of aspects. First of all, obviously the cost. With a large size of systems, such as over 10 megawatt, it is probably better to leaning towards to central. However, as we all know, central inverters means that someone needs to be going on site in a very short time in case there's any failures. And there needs to be, the inverter has to be fixed, not replaced. So if the location, or let's say our service hub, is really far away from the location, yeah, in that case, maybe that the customer needs to go back to the drawing board and check with the 5 years or 10 years or even 20 years of serviceability, the additional cost on that, whether it can go through, compared to the string inverters. But having said that, let's say in Australia, we do have a lot of large-scale projects that's been installed, getting commissioned. And as we all know, Australia has really, really remote locations. It's very far away from the nearest town. But yeah, what we still prefer, we still recommend, because of the scale of the license, it's all over 100 megawatt. Definitely, we always go to recommend our clients to go to the central solution. So at the end of the day, to summarize it, I reckon there's no, it's no good and bad, or it's all up to our clients that they need to decide. And yes, of course, from our point of view, we will give them the pros and cons. We let them decide what is the best for them. Yeah, but we won't say, oh, I'll tell you what, go string is best, or go central, that will be the best. That's not the way SMA will this question. Yeah,
understood. No, a good way of answering that one, I think, especially the time that we have. So I guess we've got time maybe for one more. So Ray, you talked at the end about the manufacturing capacities. So just make people aware. I mean, you've got manufacturing plants, outside of China. What are those plants actually for? Do they supply other markets like the US or Europe? How do they operate?
For our international factories, currently they are mainly set up to supply to the US market, because we are actually having the same quality control, and all the production line is exactly the same. But the overseas factories, the cost is actually a little bit higher. But for our open market, like Europe, like the Asia Pacific market, and the priority is still to shipping from China. That's our current situation right now.
Okay. Well, looking at the time, thank you. We've come to the end of the webinar and the Q&A session. So Ray, thank you very much for your presentation and your answers. Charles, the same. Thank you very much, and a good day to everybody here that's attended this webinar. We've had a lot of people on and have stayed with us all the way through. So once again, thank you to the attendees, and we hope to speak to you and see you again in the near future. Just to let people know, the actual questions area here will stay open for a short time. So if you still have any questions, I think there's 1 or 2 still coming in, then staff from both SMA and Seraphim are here to help. But thank you once again, everyone, for being here today, and we'll see you soon. Thank you. Bye-bye.
Thanks, Mark. Thanks.
Thank you, Mark, and thanks everyone for your participation. Thank you.